Seen how we were using a simple linear model, and we have come up to 83% accuracy in PyTorch we have built. Okay, now for device agnostic code, right, we have first checked the device, and let's try to build a better model. And how the better model, everything will remain same. Okay, only we are going to apply activation non-linear activation function after the linear layers. Okay, so instead of a separate instead of combined entity, start to think about your activations as separate entity or separate functions. So once your wx plus b, that calculation happens, then it goes into the activation for each neuron separately, and the activation happens. So instead of combining it like we used to write in tensors using sequential, you can start thinking of activation as a separate layer itself. And that's it for this you know model. So once the model is built, same thing, we are just going to call. And what we are going to do, this .to device will make sure if our data is in GPU, okay, then our model is also in GPU. Okay, here you can see I have turned on my GPU version, so you can see the device is connected to one GPU, and then again the same loss and optimizer, and then the training and testing. Okay, definition of the training and testing step that we have already performed. We just make it as a function to run reusing purpose. So now for again same, for 3 epoch we are going to train with 32 size batch number. So once after training, when we are testing for model by writing this evaluate model, you can see it gives us error. Why it is giving error? Because all the tensors needs to be in same device in PyTorch. Okay, but we have seen, right, our data, when we are calculating, the data is in CPU and not in GPU. That's why it is throwing error basically. So in the next step, in this step, we have make sure, okay, that this does not happen, where here we are just passing the device as well, from which it should check the given data as well as the module as well as the model. So here we have made this change, and the same code will work again for this model. So you can see the model's performance here as well. Now for any image classification or image related neural network, mostly convolutional neural network, it performs better. So how convolutional neural network works: first you will have the input layer, then you will have convolutional layer. The convolutional layer is nothing but a filter kind of grid that will find all the relevant pixels or the important steps, that means edges or nodes, the direction, the positions, locations where it is located, all those details it will store in this convolutional layers. Okay, then you will have non-linearity, that means your activation layers, then you will have the pooling layer, and finally you will have the output layer. And convolutional neural network is particularly known for its convolutional activation and pooling layer. Okay, now there must be one question ki CNNs are good for images, or is there any kind of model that we should be aware of? Okay, so this table that states that for any structured data, normally gradient boosting algorithms, random forest or XGBoost, this works better. So you have XGBoost library, sklearn ensemble libraries. For unstructured data, mostly your language, audio, images, you have RNN, CNN, transformers. So for transformers you have to see Hugging Face, and for all the other purposes, mostly your torch contains all those layers that you can implement or utils. Okay, so here now instead of inside your sequential, instead of your directly flattening and passing off your non-linear ReLU functions, we are using convolutional layer. In convolutional layer you will need to pass the input, then you need to pass the output, and in output we are passing the hidden units. Then you, in the filter, that convolutional filter, you need to pass the filter size. Is there any striding required or padding required? So these are the steps you need to mention inside your con2d function. Once that is done, as we have mentioned here, right, first convolution happen, and then non-linearity activation needs to be provided. So here again ReLU function we are providing. Again you can see there is again another convolutional layer, another activation, and finally we are calling one max pool. So you can also have a pooling layer here based on your requirement, and this is your first block. And in the second block, again another convolutional layer I am calling. Then we are passing non-linearity, then again another convolutional layer I'm calling, then again one non-linearity, and then we are passing or calling one pooling layer basically. And finally in the classification section, that means output, what will happen, we are calling one linear function where we are passing the hidden unit, and in output we are passing the output shape. Okay, so that's it basically for your model building. Once the model is built, in forward, first we are passing it to block 1, then block 2, and then the classifier. And it is more or less same, and as we are performing platform agnostic thing, so this .2 device, it will make sure that our model will always, model and data will always resides in same device. So once that is done, you can see how it looks like, what will be the structure of the model. And once that is done, there are some information regarding what convolutional layer is and how to work with convolutional neural network. This is not part or scope of this tutorial. This scope is mostly learning the structure of PyTorch basically, so I'm not dealing here. So here finally you can see how your image's size or how your image will look like. So here I have taken one random tensor where the size will be mostly your batch size, then your number of color channels, then your pixel size. Okay, that means h and w. Once that is done, okay, you can see the shape, and then single image shape will be 3,64,64 in the next line, and in the third line I'm just printing as it's all random values. You can see the tensor how it will look like. Okay, and I'm just skipping all those because these are not part of the scope. And then directly come to this position where we are going through the training. So here you can see we are defining again the loss and optimizer. So once loss and optimizer is set perfectly, then we will perform the train and test again, and we have created all the train step and test step, right? The functions, we are just calling those. Here again you are passing the data loader. The data loader contains the dataset, and the dataset contains all the transformation. So everything is in shape. You are passing the device for your agnostic behavior of your PyTorch learning. You are passing the loss, optimizer, and any other functions that required. So as we are interested in accuracy as well, so we are passing the accuracy function that's customly built, and then we are again checking the train and test behavior, and you can see a improved accuracy here, which is 88%. And then finally what is happening, we're just comparing all the model and their accuracy. So you can see the model with convolutional neural network performs a bit better. So yeah, that's it. I'm not going much deeper. You can get this notebook and you can go through on your own in your free time. So this is just to give you an understanding how you can build any simple or complex neural network or deep neural network for your project or for your company in your day-to-day job using PyTorch. The basics that needs to be understood: the data loader portion, dataset portion, and transformation portion. So I will bring more hands-on tutorials here. I haven't typed much code, but in that portion so we'll be typing much more codes, and we'll understand how to build complete structure projects, and you will understand every bit of PyTorch, and will be interview ready for your